Sunlight is a portion of the electromagnetic radiation given off by the Sun, in particular infrared, visible, and ultraviolet light. On Earth, sunlight is filtered through the Earth's atmosphere, and is obvious as daylight when the Sun is above the horizon. When the direct solar radiation is not blocked by clouds, it is experienced as sunshine, a combination of bright light and radiant heat. When it is blocked by the clouds or reflects off other objects, it is experienced as diffused light. The World Meteorological Organization uses the term sunshine duration to mean the cumulative time during which an area receives direct irradiance from the Sun of at least 120 watts per square meter. The ultraviolet B component of sunlight on the skin is an effective source of vitamin D3 from serum cholesterol. Summary: sunlight may be recorded using a sunshine recorder, pyranometer, or pyrheliometer. Sunlight takes about 8.3 minutes to reach the Earth from the surface of the Sun. A photon starting at the center of the Sun and changing direction every time it encounters a charged particle would take between 10,000 and 170,000 years to get to the surface. The total amount of energy received at ground level from the Sun at the zenith depends on the distance to the Sun and thus on the time of year. It is about 3.3% higher than average in January and 3.3% lower in July. If the extraterrestrial solar radiation is 1367 watts per square meter, then the direct sunlight at the Earth's surface when the Sun is at zenith is about 1050 watts per meter too, but the total amount hitting the ground is around 1120 watts per meter too. In terms of energy, sunlight at the Earth's surface is around 52 or 55% infrared, 43 or 42% visible, and 5 or 3% ultraviolet. At the top of the atmosphere, sunlight is about 30% more intense, having about 8% ultraviolet, with most of the extra UV consisting of biologically damaging shortwave ultraviolet. Direct sunlight has a luminous efficacy of about 93 lumens per watt of radiant flux, higher than most artificial lighting, including fluorescent. Multiplying the figure of 1050 watts per square meter by 93 lumens per watt indicates that bright sunlight provides an illuminance of approximately 98,000 lux on a perpendicular surface at sea level. The illumination of a horizontal surface will be considerably less than this if the Sun is not very high in the sky. Averaged over a day, the highest amount of sunlight on a horizontal surface occurs in January at the South Pole. Sunlight is a key factor in photosynthesis, the process used by plants and other autotrophic organisms to convert light energy, normally from the Sun, into chemical energy that can be used to fuel the organism's activities. Composition and power. The spectrum of the Sun's solar radiation is close to that of a black body with a temperature of about 5,800 K. The Sun emits EM radiation across most of the electromagnetic spectrum. Although the Sun produces gamma rays as a result of the nuclear fusion process, these super-high-energy photons are converted to lower-energy photons before they reach the Sun's surface and are emitted out into space. As a result, the Sun does not emit gamma rays. The Sun does, however, emit X-rays, ultraviolet, visible light, infrared, and even radio waves, not to mention neutrinos. Although the solar corona is a source of extreme ultraviolet and X-ray radiation, these rays make up only a very small amount of the power output of the Sun. The spectrum of nearly all solar electromagnetic radiation striking the Earth's atmosphere spans a range of 100 nm to about 1 ohm. This band of significant radiation power can be divided into 5 regions in increasing order of wavelengths: ultraviolet C or range, which spans a range of 100 to 280 nm. The term ultraviolet refers to the fact that the radiation is at higher frequency than violet light. Owing to absorption by the atmosphere, very little reaches the Earth's surface. This spectrum of radiation has germicidal properties, and is used in germicidal lamps. Ultraviolet B or range spans 280 to 315 nm. It is also greatly absorbed by the atmosphere, and along with UVC is responsible for the photochemical reaction leading to the production of the ozone layer. It directly damages DNA and causes sunburn. Ultraviolet A or spans 315 to 400 nm. This band was once held to be less damaging to DNA, and hence is used in cosmetic artificial sun tanning and PUVA therapy for psoriasis. However, UVA is now known to cause significant damage to DNA via indirect routes, and is able to cause cancer. Visible range or light spans 380 to 780 nm. As the name suggests, it is this range that is visible to the naked eye. It is also the strongest output range of the Sun's total irradiance spectrum. Infrared range that spans 700 nm to 106 nm. It is responsible for an important part of the electromagnetic radiation that reaches the Earth. It is also divided into three types on the basis of wavelength: infrared A, 700 nm to 1400 nm, infrared B, 1400 nm to 3000 nm, infrared C, 3000 nm to 1 ohm. Published tables of direct solar radiation on various slopes from 0 to 60 degrees north latitude, in calories per square centimeter were issued in 1972 are published by Pacific Northwest Forest and Range Experiment Station Forest Service, U.S. Department of Agriculture, Portland, Oregon, USA. Calculation: to calculate the amount of sunlight reaching the ground, both the elliptical orbit of the Earth and the attenuation by the Earth's atmosphere have to be taken into account. The extraterrestrial solar illuminance, corrected for the elliptical orbit by using the day number of the year, is given to a good approximation by where dn equals 1 on January 1. dn equals 2 on January 2. dn equals 32 on February 1, etc. In this formula dn3 is used, because in modern times Earth's perihelion, the closest approach to the Sun and, therefore, the maximum ext occurs around January 3 each year. The value of 0.033412 is determined knowing that the ratio between the perihelion squared and the aphelion squared should be approximately 0.935338. The solar illuminance constant is equal to 128A, 103 Lx. The direct normal illuminance, corrected for the attenuating effects of the atmosphere, is given by where C is the atmospheric extinction and m is the relative optical air mass. The atmospheric extinction brings the number of lux down to around 100,000. Solar constant. The solar constant, a measure of flux density, is the amount of incoming solar electromagnetic radiation per unit area that would be incident on a plane perpendicular to the rays, at a distance of 1 astronomical unit. The solar constant includes all types of solar radiation, not just the visible light. Its average value was thought to be approximately 1.366 a kilowatt-mass squared, varying slightly with solar activity, but recent recalibrations of the relevant satellite observations indicate a value closer to 1.361 a kilowatt-mass squared is more realistic. Total and spectral solar irradiance upon Earth. Total solar irradiance the amount of solar radiation received at the top of the Earth unregistered trademark S atmosphere has been measured since 1978 by series of overlapping NASA and ESA satellite experiments to be 1.361 kilowatts per square meter. TSI observations are continuing today with the ACRAMSAT ACRIM-3, SOHO Virgo and SOACETIM satellite experiments. Variation of TSI has been discovered on many timescales including the solar magnetic cycle and many shorter periodic cycles. TSI provides the energy that drives the Earth's climate, so continuation of the TSI time series database is critical to understanding the role of solar variability in climate change. Spectral solar irradiance, the spectral distribution of the TSI, has been monitored since 2003 by the SOACE Spectral Irradiance Monitor. It has been found that SSI at UV wavelength corresponds in a less clear, and probably more complicated fashion, with Earth's climate responses than earlier assumed, fueling broad avenues of new research in a Earth connection of the Sun and stratosphere, troposphere, biosphere, ocean, and Earth unregistered trademark S Climatea Intensity in the solar system. Different bodies of the solar system receive light of an intensity inversely proportional to the square of their distance from Sun. A rough table comparing the amount of solar radiation received by each planet in the solar system follows. The actual brightness of sunlight that would be observed at the surface depends also on the presence and composition of an atmosphere. For example, Venus' thick atmosphere reflects more than 60% of the solar light it receives. The actual illumination of the surface is about 14,000 lux, comparable to that on Earth in the daytime with overcast clouds. Sunlight on Mars would be more or less like daylight on Earth wearing sunglasses, and, as can be seen in the pictures taken by the rovers, there is enough diffuse sky radiation that shadows would not seem particularly dark. Thus, it would give perceptions and feel very much like Earth daylight. For comparison purposes, sunlight on Saturn is slightly brighter than Earth sunlight at the average sunset or sunrise. Even on Pluto the sunlight would still be bright enough to almost match the average living room. To see sunlight as dim as full moonlight on Earth, a distance of about 500 AU is needed. There are only a handful of objects in the solar system known to orbit farther than such a distance, among them 90,377 SNA and 2,067. Surface illumination. The spectrum of surface illumination depends upon solar elevation due to atmospheric effects, with the blue spectral component dominating during twilight before and after sunrise and sunset, respectively, and red dominating during sunrise and sunset. These effects are apparent in natural light photography where the principal source of illumination is sunlight as mediated by the atmosphere. While the color of the sky is usually determined by Rayleigh scattering, an exception occurs at sunset and twilight. Preferential absorption of sunlight by ozone over long horizon paths gives the zenith sky its blueness when the sun is near the horizon. See diffuse sky radiation for more details. Climate effects. On Earth, solar radiation is obvious as daylight when the sun is above the horizon. This is during daytime, and also in summer near the poles at night, but not at all in winter near the poles. When the direct radiation is not blocked by clouds, it is experienced as sunshine, combining the perception of bright white light and warming. The warming on the body, the ground, and other objects depends on the absorption of the electromagnetic radiation in the form of heat. The amount of radiation intercepted by a planetary body varies inversely with the square of the distance between the star and the planet. The Earth's orbit and obliquity change with time, sometimes forming a nearly perfect circle, and at other times stretching out to an orbital eccentricity of 5%. As the orbit changes, the total insolation over a year remains almost constant due to Kepler's second law. Where is the aerial velocity invariant? That is, the integration over the orbital period is a constant. If we assume the solar radiation power P as a constant over time and the solar irradiation given by the inverse square law, we obtain also the average insolation as a constant. But the seasonal and latitudinal distribution and intensity of solar radiation received at the Earth's surface also varies. For example, at latitudes of 65 degrees, the change in solar energy in summer and winter can vary by more than 25% as a result of the Earth's orbital variation. Because changes in winter and summer tend to offset, the change in the annual average insolation at any given location is near zero, but the redistribution of energy between summer and winter does strongly affect the intensity of seasonal cycles. Such changes associated with the redistribution of solar energy are considered a likely cause for the coming and going of recent ice ages. Past variations in solar irradiance. Space-based observations of solar irradiance started in 1978. These measurements show that the solar constant is not constant. It varies on many periodic cycles including the 11-year sunspot solar cycle. When going further back in time, one has to rely on irradiance reconstructions, using sunspots for the past 400 years or cosmogenic radionuclides for going back 10,000 years. Such reconstructions have been done. These studies show that solar irradiance does vary with distinct periodicities such as 11 years, 88 years, 208 years and 1,000 years. Life on Earth. The existence of nearly all life on Earth is fueled by light from the sun. Most autotrophs, such as plants, use the energy of sunlight, combined with carbon dioxide and water, to produce simple sugars, a process known as photosynthesis. These sugars are then used as building blocks and in other synthetic pathways that allow the organism to grow. Heterotrophs, such as animals, use light from the sun indirectly by consuming the products of autotrophs, either by consuming autotrophs, by consuming their products, or by consuming other heterotrophs. The sugars and other molecular components produced by the autotrophs are then broken down, releasing stored solar energy, and giving the heterotroph the energy required for survival. This process is known as cellular respiration. In prehistory, humans began to further extend this process by putting plant and animal materials to other uses. They used animal skins for warmth, for example, or wooden weapons to hunt. These skills allowed humans to harvest more of the sunlight than was possible through glycolysis alone, and human population began to grow. During the Neolithic Revolution, the domestication of plants and animals further increased human access to solar energy. Fields devoted to crops were enriched by inedible plant matter, providing sugars and nutrients for future harvests. Animals that had previously provided humans with only meat and tools once they were killed were now used for labor throughout their lives, fueled by grasses inedible to humans. The more recent discoveries of coal, petroleum and natural gas are modern extensions of this trend. These fossil fuels are the remnants of ancient plant and animal matter, formed using energy from sunlight and then trapped within the earth for millions of years. Because the stored energy in these fossil fuels has accumulated over many millions of years, they have allowed modern humans to massively increase the production and consumption of primary energy. As the amount of fossil fuel is large but finite, this cannot continue indefinitely, and various theories exist as to what will follow this stage of human civilization. Cultural aspects. The effect of sunlight is relevant to painting, evidenced for instance in works of Claude Monet on outdoor scenes and landscapes. Many people find direct sunlight to be too bright for comfort, especially when reading from white paper upon which the sun is directly shining. Indeed, looking directly at the sun can cause long-term vision damage. To compensate for the brightness of sunlight, many people wear sunglasses. Cars, many helmets and caps are equipped with visors to block the sun from direct vision when the sun is at a low angle. Sunshine is often blocked from entering buildings through the use of walls, window blinds, awnings, shutters, curtains, or nearby shade trees. In colder countries, many people prefer sunnier days and often avoid the shade. In hotter countries, the converse is true. During the midday hours, many people prefer to stay inside to remain cool. If they do go outside, they seek shade that may be provided by trees, parasols, and so on. In Hinduism, the sun is considered to be a god as it is the source of life and energy on earth. Sunbathing. Sunbathing is a popular leisure activity in which a person sits or lies in direct sunshine. People often sunbathe in comfortable places where there is ample sunlight. Some common places for sunbathing include beaches, open-air swimming pools, parks, gardens, and sidewalk cafes. Sunbathers typically wear limited amounts of clothing or some simply go nude. For some, an alternative to sunbathing is the use of a sunbed that generates ultraviolet light and can be used indoors regardless of outdoor weather conditions and amount of sunlight. Tanning beds have been banned in a number of states in the world. Women often try to shift or remove clothing straps from areas that would be exposed by a different style of clothing. This means the area gets some tan and strap marks are not too obvious. One way this is done is to remove straps while lying face down, so as to avoid being seen topless. Another way is to adjust the straps slightly a few times while tanning. For many people with pale or brownish skin, one purpose for sunbathing is to darken one's skin color, as this is considered in some cultures to be beautiful, associated with outdoor activity, vacations, holidays, and health. Some people prefer naked sunbathing so that an all-over, or even tan can be obtained, sometimes as part of a specific lifestyle. For people suffering from psoriasis, sunbathing is an effective way of healing the symptoms. Skin tanning is achieved by an increase in the dark pigment inside skin cells called melanocytes, and it is actually an automatic response mechanism of the body to sufficient exposure to ultraviolet radiation from the sun or from artificial sun lamps. Thus, the tan gradually disappears with time, when one is no longer exposed to these sources. Effects on human health. The body produces vitamin D from sunlight, and excessive seclusion from the sun can lead to deficiency unless adequate amounts are obtained through diet. Sunburn can have mild to severe inflammation effects on skin. This can be avoided by using a proper sunscreen cream or lotion or by gradually building up melanocytes with increasing exposure. Another detrimental effect of UV exposure is accelerated skin aging, which produces a cosmetic effect that is difficult to treat. Some people are concerned that ozone depletion is increasing the incidence of such health hazards. A 10% decrease in ozone could cause a 25% increase in skin cancer. A lack of sunlight, on the other hand, is considered one of the primary causes of seasonal affective disorder, a serious form of the winter blues. SAD occurrence is more prevalent in locations farther from the tropics, and most of the treatments involve light therapy, replicating sunlight via lamps tuned to specific wavelengths of visible light, or full-spectrum bulbs. A recent study indicates that more exposure to sunshine early in a persona unregistered trademark S life relates to less risk from multiple sclerosis later in life. In January 2014, British researchers found that sunlight may lower blood pressure, a dangerous factor for heart attacks and stroke. It was reported that 20 minutes of ultraviolet A sunlight lowered blood pressure by a small but significant amount by dilating blood vessels and easing hypertension. The Journal of Investigative Dermatology tested 24 volunteers and found that the sun increases nitric oxide levels, a chemical linked to blood flow, and results in lowered blood pressure. This research supports the claim of Richard Weller of the University of Edinburgh and Martin Fialish of the University of Southampton, who found that people who live in the darker north have higher rates of heart disease. They concluded, "We are concerned that well-meaning advice to reduce the comparatively low numbers of deaths from skin cancer may inadvertently increase the risk of death from far higher prevalent cardiovascular disease and stroke, and goes against epidemiological data showing that sunlight exposure reduces all-cause and cardiovascular mortality." See also. References. Further reading, Hartman, Dom. The Last Hours of Ancient Sunlight. London, Hodder and Stoughton. ISBN 0-340-82243-0. External links, media related to sunlight at Wikimedia Commons, solar radiation, Encyclopedia of Earth, total solar irradiance daily mean data at the website of the National Geophysical Data Center, construction of a composite total solar irradiance time series from 1978 to present by World Radiation Center. Physikalisches Meteorologisches Observatorium Davos. A comparison of methods for providing solar radiation data to crop models and decision support systems, Rivington al. Evaluation of 3 model estimations of solar radiation at 24 UK stations, Rivington al. High-resolution spectrum of solar radiation from Observatoire de Paris, measuring solar radiation. A lesson plan from the National Science Digital Library. Week's Earth astronomical information, online tools for calculating rising and setting times of sun, moon or planet, azimuth of sun, moon or planet at rising and setting, altitude and azimuth of sun, moon or planet for a given date or range of dates, and more. An Excel workbook with a solar position and solar radiation time series calculator. By Greg Pelletier, DOE. Information about the ASTM standard solar spectrum for PV evaluation. ASTM standard for solar spectrum at ground level in the U.S. Detailed spectrum of the sun at astronomy. Picture of the day. Solar radiation resource.